Hello, everyone. So we're going to do a second day of quadratic formula. Most people put these together as one lesson, but I decided to split it up. It's going to be a short notes. The only difference between this lesson and the last lesson is how we give our solutions. Okay. Today, we're going to give the exact solutions. Okay. So if I say give the exact solutions, this is what you're doing, which means they are given in simplest radical form. So we're going to be using radicals again. Okay. So we got 3 problems and then that's it. So I'm going to go ahead and scroll down, find the exact solutions. All right. A equals 1, B equals -1, and C equals -11. All right. So X equals negative blank plus or minus the blank square root of blank squared minus 4 blank blank all over 2 blank. Okay. We're going to fill those in. It's negative B, so B is -1, B -1, A is 1, C is -11, and A is 1. So -1 is 1, plus or minus the square root of -1 squared is also 1. Change colors just to make it stand out. Okay. Minus 4 times 1 times -11 is -44. Oops. Switch back to red. Divided by 2. So 1 plus or minus the square root of 1 minus -44 is like 1 plus 44. So that's 45 divided by 2. Okay. Now, this is where it changes. Everything up to that point has been the same. On the last lesson, the number inside the radical was either a really good number, it was a perfect square, or we said round it to the nearest 10th or 100th or whatever the rounding was. This one, square root of 45 is not a good number, but if I want the exact solution, I can't round it. So what I need to do is break it down. So we go back to unit 8 here, which hopefully all of you remember this. This wasn't that long ago. So it's 3 radical 5. So square root of 45 becomes 3 radical 5. So I'm going to change colors just to show you the difference here. 1 plus or minus, instead of square root of 45, I'm going to put 1 or 3 radical 5 over 2. Now the good news is you're done. You do want to check and see if you can reduce, but I can't reduce anything here. I'm going to show you one that you can, but this one you can't. So 1 plus or minus 3 square root of 5 all over 2. Okay, those are your answers. Now that I said answers, plural, hopefully you caught that plus or minus makes it 2 answers. It's 1 plus 3 radical 5 over 2, and then 1 minus 3 radical 5 over 2. But that is an exact answer. Okay. Go ahead and do another one. I'll leave it blue. X equals negative blank plus or minus square root of blank squared. Oops. Minus 4AC all over 2A. So B is -10. -10 again. A is 7. C is 1. 7. -10 is +10. -10 squared is 100. Then switch colors again. 4 times 7 times 1 is 28. Divided by 14. And we're at that point where we need to break it down. So I'm going to go over here and break down 72. 12 and 6. 6 and 2. 3 and 2. 3 and 2. So I've got a pair of 2s and a pair of 3s. That's 6 on the outside, radical 2 left over. All right. This one is a little trickier, and you'll see why here in a second. So I've got X equals 10 plus or minus 6 radical 2 over 14. Now, I mentioned in the last problem that we have to check and see if we can reduce. This one does reduce, but it doesn't reduce the way you would think. To reduce, I need to reduce all three numbers on the outside. Okay. If I have something like that, okay, all of those numbers can be divided by 2. I need to divide all three of those by 2. All right, so 10 divided by 2 is 5. Still have plus or minus. 6 divided by 2 is 3. The number inside the radical does not get reduced. Please don't reduce that one. And 14 divided by 2 is 7. Okay, there's a reason for that. I'm going to show you real quick. If I write 10 plus or minus 6 radical 2 over 14, a way of splitting that into 2 problems is to put the denominator with both numerators like that. Okay, so in that case, you can see that this reduces to 5 over 7, and this reduces to 3 radical 2 over 7, right? They both reduce because 6 and 14 are both even, 10 and 14 are both even, okay? Let's say, I'm gonna go ahead and clear that. We're done with that problem. But let's say we have something like this, where we get to the end and it's x equals 10 plus or minus 3 radical 2 over, let's say 8. Okay, a lot of people think, oh, I can reduce that down to 5 plus or minus 3 radical 2 over 4. You can't. Let me show you why. 10 over 8 plus or minus 3 radical 2 over 8. I can reduce this to 5 over 4, but I can't reduce the other one. So what I would have is that. Now my denominators are different and I can't put those together. So you only want to reduce when all 3 numbers outside the radical are reducible. All right. Little summary here. How many solutions did each problem have? There were 2. Is that always going to be the case? No. But with this example, I just wanted you to see that plus or minus means you have 2 solutions. And then reiterate this, to reduce in these problems, you need to be able to divide a number out of all 3 numbers or all of the numbers on the outside of the radical. So let's do another problem. Find the exact solutions is what you'll see me say. I need to get a equal to 0 before I start, so I got to subtract 3. Okay. So I get 2x squared plus 6x minus 3 equals 0. So that's my starting point here. All right, so x equals negative blank plus or minus the square root of blank squared minus 4 blank blank. All right, b is 6, a is 2, c is negative 3, a is 2. All right, so negative 6 plus or minus the square root of 36 minus 4 times 2 is 8. 8 times negative 3 is negative 24. Okay, divided by 4. So I get x equals negative 6 plus or minus the square root of 36 plus 24 is 60 divided by 4. I'm going to save us some time here. I'm just going to, you know how to break down 60, hopefully. When you break that down, you get x equals negative 6 plus or minus 2 radical 15 divided by 4. Can I reduce it? Hopefully you see that you can. All 3 of those divide by 2. You get x equals negative 3 plus or minus 1. You can write the 1, but I'm not going to write it. Square root of 15 all over 2. Okay, and that's it for this lesson. Those are called exact solutions. We've got 2 lessons left, and then we'll be done.